I am on page 51 in the textbook, and this is talking about scale models and scale factors. So before we get into this one, I want to tell you about similar figures. So just put the textbook aside for a second and let's think through this problem that I want to show you. This is actually a true situation that I just recently found myself in. I purchased one of those little portable cameras, and it takes it prints awesome little pictures. I just don't like them because they're so small. The photos are only about 2 inches by 3 inches. They come on sticky back paper, which that's really cool, and I use it. But there are some of the photos that I have that I really would like to enlarge. I want them to be bigger than this little sticker size. And that's where the concept of similar figures comes in. So I can send this little print or take this little print to Walmart and have an enlargement made so that the photo that I'm enlarging will be 6 inches by 4 inches. Now, if I use math, I can show you that these are indeed proportional, that the 3 to 2 and the 6 to 4 are similar figures, because remember this process? 3 times 4 is 12, and 2 times 6 is 12. So the cross products are equal. The problem is proportionate. These are similar figures. And the rule that you need to know is that similar figures, it's late, guys, it's almost 1 o'clock, are proportional. Or proportionate. Let's use proportionate. Okay, so they follow that proportion math rule. That's the proper way to say that, and we use cross products to prove it. But I want you to think of it this way, in just everyday common sense terms. I want you to imagine that this is the baby figure, and that this is the mama figure, or the daddy figure, the parent figure. Okay, the two are proportionate. So let's look at another example. Let's take this baby figure and this mama figure. Does that mama go with that baby? No. Look at the shapes. So here's baby, that's a rectangle. Mama is a triangle. Those do not go together. They're not similar. So just because you draw two shapes, it doesn't mean that they're going to be similar. What about this one? Let's take this baby and this mama, and let's give them some dimensions of 2 inches and 3 inches. And then let's give this one 8 inches and 9 inches. And let's see what we think. Do you believe that those two are mama and baby? Well, they look like they could be. They're definitely both right triangles. But you can't rely on your eyes. You have to do the math to see. Now, in this example, I could rely on my eyes because they're not the same shape. But in this one, they could be or they may not be. I need to do the math to see. So I'm going to set up baby and mama. And let's test. We want to know if they're equal. So we have 3 times 8. That's 24. And then 2 times 9. These are not similar. Or those cross products would be similar. So I can tell you that these are not mama and baby. This is another one of those situations where I have baby that looks like mama. Maybe they're aunt and niece, but they're not mama and baby. They're definitely in the same family. They share some of the same genetics, but they're not directly connected. They're not mama and baby or daddy and baby. So the point there is don't rely just on your vision. You need to do the math and see if you have a proportionate situation. Okay, let's look at example 3. Now, before we even read example 3, I want to take care of something right here. So go ahead and draw yourself a baby triangle. It's a baby right. It's actually the one I just drew up there, isn't it? So we have 2 inches and 3 inches. And this baby is named A, B, C. So this is baby triangle A, B, C. And then here's mama triangle. Boy, they look alike. They're in the same family, I can tell you that much for sure. But we need to know if they're mama and baby. And mama's name is D, E, and they left off the F, but it needs to go there. So D, E, F, that's mama, D, E, F. Now this notation looks a little scary. You just have to make sure that you know how to read it. And we're going to look at that. So this is saying that determine whether triangle ABC, that's the baby. Let me get a different color on this one. So here's baby, ABC. And triangle DEF, that's mama, are similar. In other words, are they truly mama and baby? So are they similar? And if so, if they are similar, determine the scale factor from baby to mama. Okay, so to make sure they're similar, let's do 2, 3, and 6, 9, and multiply. So we have 6 times 3 is 18, and then 2 times 9 is 18. So yes, they are similar. And I'm going to show you how to find the scale factor, but let's say yes, they are similar. And I'm going to go ahead and color mama, since we know that she is indeed the mother to that baby triangle. And again, guys, if you want to say this in proper math, you would say that their triangle ABC and triangle DEF are proportionate. They're similar. The mama and baby stuff is just my words to help you understand. The question is, what is the scale factor? And to find that, you need to write these fractions again. But this time, instead of drawing peanuts, I want you to draw 2 boxes here. What do you multiply by 2 to get 6? 2 times 3, right? And that same 3 will work down here to get 3 times 3 is 9. So the scale factor is 3. So yes, they are similar, and the scale factor is 3. When you see mama and baby, think of a proportion. Make sure it's a proportion, that's with peanuts. And then once you get the peanuts, if those prove to be true, if that's a true proportion, then you can get your scale factor. Okay, in the margin on this page, there is a problem called the 21st century skill. So let's take a look at that one. Urban planners or city planners often rely on scale models of skyscrapers to examine existing structures and to design new ones. To use the scale of a building or map, write a proportion. Be sure to keep units in mind. For example, to solve the following problem, you need to convert inches to feet. A model of a skyscraper is built at a scale of 1 to 800, and the model's height is 14.4 inches. What is the height of the actual skyscraper in feet? So if we sketch this problem, we have a little model that an architect might build in her office. Let me straighten this up because it needs to be straight. And we're going to build an actual skyscraper based on this model. So it's important that that model is right. It needs to be accurate. So I'm going to take a copy of that and literally enlarge it. So here's the actual skyscraper. It's a good thing I don't build skyscrapers because that's crooked, but it'll work. Okay, in the model, we are looking at a scale. Let me write this down. The scale is 1 to 800. Now on the scale, you're always, well, you won't always, but we're going to say that the model is first and the actual is the big number. So 1 foot on the model equates to 800 feet on the skyscraper. And we know that the model is 14.4 inches tall. Now that is a serious problem because I have feet, inches, feet. That can't happen. I need all feet or all inches. So I'm going to convert the 14.4 inches. And anytime you convert something, you can use a proportion. I know that the basic conversion of inches to feet is 12 inches equal 1 foot. So I want to convert the 14.4 inches. So I'll say 14.4 divided by 12 on my calculator. I think it's 1.2, but I'm not sure. I don't even know why I think it's 1.2. It is 1.2. My brain just knew that, I guess. I don't know. But that's 1.2 feet. And that's what we need to put on this model. So that now we have foot, feet, and feet. They're like units. And once you get that, you can solve this problem. So we will take the model of 1 to 1.2 and the skyscraper that is 800 and then the unknown, and we'll multiply those two. And that is 960 divided by 1 is 960 feet. So the missing piece in this skyscraper is 960 feet tall. I'm using the model to predict what the actual will look like. That's the purpose of a model. And that's really the purpose of a scale. Okay, let me bring this down here. And then we'll take a look at the Think About math. I would like for you to try those. And then you can just pause your video. And when you get ready, go ahead and click Start. And we'll look at those two problems right here in this section. Number 1, this is Think About Math. A photography studio enlarged a photograph that was 8 inches wide and 9 inches long. So I'm going to start with a baby photograph that was 8 inches wide and 9 inches long. And I'm using this as my length and 8 inches as my width. To a similar photograph, so they're telling me that this is the mama to that baby. If it's similar, they've already done the math to know that this mama and that baby go together. Just pretend that mine are exactly the same. So mama is 36 inches long. That's the length. And we want to know how wide the enlargement will be. So we do have mama and baby. They told me that with the word similar. We do not have to worry about that. We just have to solve the proportion. So we have 9 to 8 equals 36 to some unknown. And we're going to multiply the peanut. So 8 times 36 is 288. And divide that by 9. So mama is going to be 32 inches wide. Okay. And then number 2 says, what scale factor did the photography studio use to enlarge the photograph? So we've got baby and we've got mama. We need to know the scale factor. And that's going to be these boxes that we need to work with. So 9 times 4 is 36, and 8 times 4 is 32. So the scale factor is 4. They enlarged the photograph 4 times.